Hey guys, this is Mr. Matthews, and your first assignment tonight is to establish a graph in your lab journals. And so what you guys want to do right now is go ahead and find your lab journal and open up to page 9 or 10. You may want to just pause the clip just to make sure that you are looking at what I am. So on page 9 or 10, you're going to find about all the way down the page, you're going to see a graph that says density graph, and you're also going to see graphing commandments. And so tomorrow in class, you're going to be making a graph of position and time of the ball's motion that you are looking at. And I want you guys to have a nice looking graph. We're going to do a lot of graphing in this class, and so I want you to be able to do it well. So these are the 6 things that you need to do whenever you make a graph in my class. And so the very first thing is that you're going to expand each axis far enough that the full range of data fits onto the full page. So you're going to be using a full page in your lab journal. So go ahead and turn to the next open full page in your lab journal. And let's go ahead and assume that you have collected some data that looks a little bit like this. So notice that there is a position column and a time column in my data table. And apparently my ball rolled past the 50, 100, 150, 200, and all the way to the 250 centimeter mark in these time intervals. And so we want to represent this data with a graph of position versus time. So in order to do that, let's look back at what we need to do. We need to expand each axis far enough so that the full range of data fits onto the full page. Well, what does it mean for full range of data? Well, what that means is that the y-axis needs to go from 0 to 250, and the x-axis needs to go from 0 to 2.5 at least. And we want to fit that onto the full page. So in order to do that, you should, on a full page, draw a line down the side and a line down the bottom of your page. Now, obviously, mine looks terrible. It's a good idea to use a ruler to do that. Now, whenever you make graphs, the first thing you want to do is, if you have lines, count out equal numbers of lines and figure out how many total lines you have. Let's say that every 4 lines represents 50 centimeters, something like that. If every 4 lines represents 50 centimeters, then that would mean to get to 250, that is going to be, how many lines? You are going to need 4 times 5, 20 different marks in order to fit them all on there. So take the time to make sure that you have equal spaces between equal intervals of position. So I'm going to go ahead and go, let's say every 3 lines just to be fun. So 50, and then here is 100, 150. Oh, I am not doing a very good job of fitting my data on here. And then 200, and then 250. Okay, now obviously that looks awful. And you guys can make fun of me for that in class tomorrow, and that's fine. Just make sure that you space them out equally. And the other thing you're going to need to do is make sure that you label the axes appropriately. So this is position. So I'm going to write position. Oh, that works wonderful. In centimeters. So there's my position in centimeters. Over on this axis, if you do not have graph paper, then you're going to actually have to pull out a ruler and measure out set distances and mark them. So I'm going to just say I had a ruler and I measured 1 inch, 2 inches, and 3 inches, and this is going to be 1, 2, and 3 seconds. So then I'm going to label time down here with the unit. So then the last thing I'm going to do is, this is the motion of ball on track. I'm going to put a title here that tells me a little bit about what I'm graphing. If you aren't really sure what you're graphing, then you can just label it position versus time graph of a ball or something like that. And that is a reasonable title. So when you come to class, I'm going to expect to see a full page with a position versus time axes marked on there, and I need to see equally spaced time intervals. Please go all the way out to at least 3 seconds, since your time data is likely going to be somewhere around 2.5 to 3 seconds. So scaling wise, when you are thinking about your scaling, look at the largest time value, and that needs to be furthest to the right. The largest position value needs to be near the top of your page. So hopefully you guys come to class tomorrow with a nice looking graph. I will look at it when I check off your graphs. And you can also look back at the page in your journal to make sure that all the other requirements are met. All right, guys, that's all you have for tonight.